Hello everybody. Now please observe the role of autosar stacks in ADAS, Advanced Driver Assistance Systems development. Now ADAS functions require real-time processing, sensor fusion, secure communication, fault tolerance and high reliability. These are all the various requirements of ADAS. Now autosar's layers architecture and software stacks provide the necessary framework to develop, integrate and validate ADAS functionalities efficiently. Below is a detailed breakdown of how each autosar stack contributes to ADAS development. Okay, now let's talk about the system services stack in ADAS. What are the key modules of system services stack? Operating system, ECU1, watchdog manager, DET, DEM, diagnostic event manager, FIM and communication stack. Now what are all the various roles in ADAS? The real-time operating system ensures deterministic execution of ADAS tasks like object detection and collision avoidance, which requires very high level of real-time operation. Now next is managing the task priorities. Example, emergency braking must execute faster than lane keeping. Suppose a situation arises where two ADAS systems are required. This real-time operating system always manages to pick up the priority and execute that. And it also supports the multi-core processing, for example, critical for high performance ADAS ECUs. ECU state manager. ECU state manager, it manages the startup and sequence of camera, radar and initialization. Handles sleep, wake up modes and to optimize power consumption. Next comes the watchdog manager. The watchdog manager monitors ADAS functions for deadlocks or timing violations. It triggers fail-safe actions. Example, disabling autonomous driving if a critical task fails. Next comes the error manager and diagnostic event manager. This is the most important thing which logs the runtime errors. For example, sensor failures and software exceptions. Everybody knows that the importance of sensor in ADAS. So if at all there is any sensor failures, those errors are immediately logged in the diagnostic event manager. It also stores diagnostic trouble codes for OBD compliance. So even in ADAS there is something called diagnostic trouble code which is clearly stored by the OBD. Next comes the function inhibition manager. Disables non-critical ADAS features if a sensor fails. Alright, so it disables non-critical features if sensor fails. Communication manager controls communication modes. Example, enabling CAN, FlexRay, Ethernet when ADAS is active. Alright, so this communication manager where it enables all this communication when the ADAS is active is important. I am sure everybody knows what is the importance of communication. Communication is actually the nerve network which communicates data from sensor to ECU and within the ECU and also from ECU to the actuator. Now, what are the various memory services stacked in the ADAS? Key modules like non-volatile memory, FEE, FLS, all these are key modules. And coming to their role, the non-volatile RAM manager, it stores the calibration data. Example, camera alignment parameters, and it also retains the ADAS configuration settings. For example, adaptive cruise control preferences have their own configuration settings. And coming to flash EEPROM emulation, it ensures frequent updates. It also prevents wear out of flash memory due to constant writes. The flash driver FLS, it enables firmware updates and for example, updating neural networks for object detection. Okay, so this is the key role of memory services when it comes to ADAS. Now coming to communication services stack in ADAS, the various communication modules are COM, PDUR, CAN if, ETIF and DCM. Okay, PDU, I already informed you what is meant by PDU. And when it comes to role in ADAS, communication common PDU router. It ensures sensor data between the ECUs. It ensures the understand this sentence very carefully. It ensures the sensor data be okay. Next ensures low latency transmission for time critical ADAS functions. And CAN interface is used for low speed ADAS functions. Ethernet is used for high bandwidth data. All right. So diagnostics, and when it comes to diagnostic communication manager, it supports the UDS for ADAS calibration and debugging. Enables remote diagnostics. All right, this diagnostic communication manager, it enables the remote diagnostic, especially which checks why automatic emergency braking has failed. Okay, to understand why a particular ADAS functionality has failed, this remote diagnostics is very useful. Now let's see the input output hardware abstraction stack in the ADAS and what is its role. This input output hardware abstraction comprises of IOH, WAB. I will clearly explain what are all these things: ADC, DIO, PWM, and ICU. Okay. Now, when it comes to input output hardware abstraction, it provides a standardized interface for ADAS sensors. Okay, it provides a standardized interface for ADAS sensors. And when it comes to ADC, it reads analog signals, example temperature sensors in LiDAR systems. Okay, so even the ADAS sensors have some analog signals. For example, in LiDAR has a temperature requirement, and that is read by ADC driver. Now, when it comes to PWM driver, it controls actuators, for example, brake-by-wire system in emergency braking. And when it comes to ICU driver, it measures pulse timing, example ultrasonic sensors, echo detection. And when it comes to crypto stack in ADAS, key modules CSM, CRY, SECOC, and what is its role in the ADAS? The role in the ADAS is crypto service manager and crypto driver, which is acronymed as CRY. It ensures secure boot, preventing unauthorized firmware modifications, encrypts OTA updates for software, for ADAS software. All right, and coming to secured onboard communications, acronymed as SECOC, it prevents the spoofing attacks. For example, fake radar signals causing false braking. Okay, and it also V authenticates V2X messages. Okay, for example, vehicle to everything, traffic signal data, all these things are taken care by the SECOC. Now, what is the role played by the complex device drivers in ADAS? The role in ADAS used for high performance non-standard ADAS functions. Bypasses autosar layers for direct hardware access. And how autosar stacks enable ADAS functions, let's see very carefully one after the other. When it comes to ACC, adaptive cruise control, the relevant autosar stack is communication and system services, and the key contributors are real-time sensor fusion and CAN Ethernet data routing. When it comes to automatic emergency braking, input output system services, fast actuator control, fault detection, lane keeping assist, operating system communication, and task scheduling, sensor data processing. Coming to parking assistance, input output and memory services are the relevant autosar stacks. And how do they contribute? They contribute by handling the ultrasonic sensors and also the calibration storage. Coming to the V2X communication, crypto and communication, these are the two relevant autosar stacks, and key contributions are secure message authentication and Ethernet support. All right, last but not the least, when it comes to OTA updates, Memory and crypto stacks are the relevant and the most important stacks. And secure firmware updates and flash management. These are extremely important contributions of memory and crypto stacks. So in conclusion, autosar standardized stacks provide necessary infrastructure. Understand this word, infrastructure. Now just like cement and iron rods form the infrastructure of a building, these stacks form the cement and iron rods for a reliable, secure and reliable time ADAS development. By leveraging system services, fault tolerant and task management. Communication stack, low latency sensor data exchange and crypto stack, protection against the cyber threats. Memory services, calibration and OTA updates. So these are all the various standardized stacks and these are all the various tasks these standardized stacks are fulfilling. Now ADAS developers can focus on the algorithm development while AUTOSAR develops hardware abstractions, communication and safety compliance. Now just to give you an idea, companies like KPIT, companies like Hella, they are experts in preparing these stacks, especially KBIT. When it comes to diagnostic stack or communication stack, these stacks are prepared by companies like KPIT, which form the foundation of the AUTOSAR layer. All right. Thank you.